Okay, so let's continue where we stopped. So this is the notes that I have, and I think we went up to, I think we went up to memory slots, right?
Yes.
Yes.
Okay. All right, so let's go to, all right, so we want to complete this part here that talks about this right here. You see my arrow?
Mm-hmm.
Okay, so understand the purpose of motherboards, CPUs, and RAM. Okay, so let's keep going here. CPUs and RAM. All right, so if we go all the way up, back up here. Exploring memory. Okay, right here. All right, so we looked at the motherboard and memory slots. What I want to look at here. All right. Let's go down. Okay. So the memory slots are, you know, they're little, should I say flat? They look like flat devices, right? And we insert them. So I think we looked at a picture the other day. Let me pull up that picture again. Memory sticks. Well, let's say memory sticks, desktop. All right. Let me hide this. Just give me 1 second. Let me change my screen a little bit here. All right, let me move this here. Just so we can have a good picture of what we're talking about. All right. All right, so the memory sticks look like this. You know, they're quite flat. Let me see, let me get a good picture. All right, so something like this, right? You install it, this green memory stick here, you install it in those slots those slots there, right? So those slots look like this. And if we look at the motherboard, you're going to see the space. Yeah, the space is right here. Right, it could be, I think it's right here, where you put the memory slots, memory sticks. Now, what does the memory stick do? So let's go and see. If I show you my control panel, so if you go here to your control panel on your computer, so you guys, I want you to do that on your computer. Do a search at the bottom left. So go to your control panel, type control. Are you getting it? Type control, and then it's going to open up your control panel. I want us to go to the control panel. So you see where your memory is on your computer. Did anybody find the control panel? Just do a search.
Yes, I find it.
Okay, so click on control panel and it's going to bring you here. All right. Now, when you get here, just go here and type name. Name, N-A-M-E, up here, name. Just type name in that corner up there. And then right here, it's going to say, see the name of this computer. Right here. See the name of this computer. So you click on see the name of this computer. And it's good. Actually, wait a second. This is not what I want to see. Just 1 second here. Okay, well, it gives you a different view here. All right. So right here, when it says see the name of this computer, now you can see right here, for me, I have installed RAM 12.0 gigabytes. May, do you see your installed RAM in your control panel?
As well, no, I used the Chromebook. I didn't find.
You have used a Chromebook?
Yeah.
I also use Chromebook.
Yeah, that's going to be difficult because this exam is based on Microsoft's products, right?
Mm.
It is based on Microsoft. So you have to speak to Quincy College to give you a Windows computer.
Oh, Windows
right?
computer. Okay.
Yes, you need a Windows computer. This Chrome is not going to be very good at all because a lot of the exam is based on Windows.
Okay.
Right? So, okay, let's go to Bantu. Do you see this installed RAM? Or anybody else?
I do. Yes, I do.
So what's yours? What does it say here in installed RAM?
800 gigabyte.
8 gigabytes. Okay, 8.
Yes.
All right, who else? Alex, what do you see?
16 gigabytes.
16
16.8.
gigabytes.
Yeah, it says in brackets.
Right here.
16.end,
Installed RAM.
8 usable.
Okay.
So it seems like
right.
not all the memory is usable. Is that right?
Yeah. Yeah. So this is how it works, right? Now, if you look at that memory stick, if we can look at that memory stick properly here, let me see if I can find one memory stick size. See if I can find a good picture for you guys here. Okay. All right. Right here. Let's see this. All right. Now, each memory stick, right, has a size. This one is a bit small. Let me see if I can. Can you see this here? 512 megabytes.
Yes.
You guys, I need to hear if you yes, no, I don't understand. I need you guys to speak.
Yeah.
Yes, I can see it.
Okay, so this one is 512 megabytes, right? This is probably an older memory stick. But basically, the way it works is this. Memory sticks, so let me go here. Memory stick is the same thing as RAM, right? Same thing as RAM. Memory stick size. All right, so if you have a size on your computer that is probably 4 gigabytes, right? So this is an older one. Let me see if I can find one that is say 4 GB. All right. Let me see if that one helps us out here. I'm I'm not seeing the sizes here. It's a bit small. Let's see if we can see another one. Usually you're going to see, which one is that? This one?
I saw 2 gigas on this one.
Yeah, well, this says 2 gigabyte. But anyway, the point is this. You have space for 4 sticks in your computer. 4 sticks. Sorry, space for 4 of those sticks, right? So depending on, what's installed on your computer, right? Like if we go back here, you can see right here, I think it allows us to do 1, 2, 3, 4. Okay? So if you have 2 gigabytes, and you have 4 of it, then you have 2, 4, 6, 8 gigabytes of memory. If you have 4 gigabytes, then you have 4 times 4. Then you have 16. What do I have? All right, so I have, let's see. Looks like I have, either I have, let me see, maybe 3. Yeah, because I don't think you have space for 6 slots, right?
Maybe
so
2
it
of
looks
4
like
and 2 of 2. No, even though.
Well, maybe. Yeah, actually, I'm surprised that it's 12. Usually, you have 2 gigabytes, 4 gigabytes. So maybe I have 3, and 1 slot is open. Usually, it should be 16. It should be 2, 4, 8, 16. Maybe I have to open up this computer and see what's inside, right? But that's how the sticks come, right? The sticks are 2 gigabytes, 4 gigabytes, and then you can have multiple on your computer, right? You can have multiple. So if you have one slot and you have maybe just 2, well, 2 is going to be too small. So the more you have, right, then the faster your computer is going to respond when you're doing things, right? When you do things on your computer, then it's going to respond based on, okay, this one here is 2 gigabytes, right? This 2 gigabytes. So if I had 4 of that, then I will have 8. I don't think there's a slot. I don't think the slots here are up to 8. So let's go back to read. Let's read a bit more of the memory sticks here and see what we can find. Processor socket. So memory slots. Okay, so first of all, it says that memory slots are easy to identify on the motherboard. First, they are long and slender, so they are like that, right? They are long long and slender, and generally close to the CPU socket. So just like that, when you open up your computer, like I showed us the other day, right? Let me get that video again, right? Where is it? Okay, I have to find the video, but we'll go back to that, at a different point. Okay. Okay, so right here, it says that the most visible part of any motherboard are the expansion slots, right? They are small plastic slots, usually from 1 to 6 inches long and approximately ½ inch wide, right? So these are your expansion slots, right? Where you install your memory sticks, right? These are pins. These pins can open up. These pins. Let me show you this again. Let's go to YouTube. Let's get something here. Okay. All right, so let's see somebody here who is installing a memory stick, right? All right, so right there, that's a good one. All right, so let's see what it's doing here. All right, so right here is pointing to those are your expansion slots, or for memory sticks. So just watch what he's going to show us here. You guys can see this?
Mm-hmm.
Yes.
Yes.
Okay. So it's going to do the installation. So that's the memory stick right there. So if you open up your computer, you can do that easily. On a desktop computer, laptops are pretty small, but on a desktop you can do this comfortably. So that's a desktop memory stick. So you can see this this little slot here, right? It's kind of like it helps you to fix it in that expansion slot right there. So just see how he does that. All right, so just like that, you just put it in there. And then you just press it down. And then you see that, you see how he put it there? You guys see how he put it there?
Yeah.
Okay. So there's only, now depending on the size, right? So there's space for 4. So he has put only 1 here. You can put another one, so you can put up to 4. Okay? So just thought I'll show us how that is. It's not very complex at all. Pretty easy to do. And then you can put it in there and take it out. So they're called expansion slots, right? You put those memory sticks in the expansion slots. Okay. All right. So that's what he was saying right there about the expansion slots. Right here, expansion slots there, about 1 to 6 inches long and approximately ½ inch wide. Those expansion slots there. Okay. All right. So there are 3. It says right here that there are 3 types of expansion slots: PCI, AGP, and PCIe. Right here, there are 3 types of expansion slots on your computer. Right, so let's see. All right, so this is an example of the PCI expansion slot. Right. So PCI stands for Peripheral Component Interconnect. It's a very big word, right? Peripheral Component Interconnect, PCI slot. All right. So PCI slots are around 3 inches long, and mostly they're white. So it says right here, 3 inches long, and they look like this, right? Generally white. If we look at the picture of that motherboard that we saw, let's see, motherboard. PCI slot. All right, so that's what it looks like. Your motherboard, your PCI slots look like this on your motherboard, something like that, right? Something like that. The PCI slot, something like that. So the white ones. So generally they're white. It says right here they're about 3 inches long. About 3 inches long right here, 3 inches long, and usually white. But you can find them with different colors, but about 3 inches long. Okay. So this PCI slots, right, are for, anyway, let's keep going. All right, so it says right here, Let's keep going. All right, so PCI expansion buses operate at 33 megahertz or 66 megahertz over a 32-bit channel, resulting in data rates of 133 megabytes per second and 266 megabits per second. Let me explain what that is. Right? Let me explain what that is, so we don't get confused about, how that works. All right, so right here, look at this box here, right? Let me just copy that box so we understand all those numbers. Let me put it here. All right, so let's go here. All right, so we're looking at the speed, right? We want to look at speed. How does speed work? Speed and data rates, right? How does it work? The speed. That is, the speed is how fast your system, right? How fast your computer can be. Okay, so let's look at it here. Right here it says, let's see, let's go to, I don't want us to be confused here, so just give me a minute. Okay. So Anu, let me ask Anu this question. When you go on the road and you're driving, how do we calculate the speed of a car? Usually in what?
By using speedometer.
Yeah, but then what is so it's like, that would tell you maybe it's kilometers per hour, right?
Yes.
Maybe it's kilometers
Per hour.
per hour,
Yes.
or per hour, miles
Yes,
per hour,
miles per hour.
mostly in the US, miles per
Yeah.
hour, okay?
Yeah.
That is, so if you want to know how fast you're going, you look at it in miles per hour or in kilometers per hour. Now, when we want to measure how fast your computer RAM is working, right, we look at it in, so let's say data speed. Data speed, we look at it in bits per second. Bits per second, right? The bits. Now, what is a bit? A bit is the smallest, let me say smallest size of data, right? A bit is the smallest size of data, or we can say smallest unit of data. Oops. Okay? A bit is the smallest unit of data. So when we talk about data, 2 megabits of data, or 4 megabytes of data, a bit is the smallest unit of data. Now, what does a bit look like? Couch, is Couch here? What does a bit, if you see a bit, how will you know this is a bit of data? Like, bit. Couch, are you here?
It's
Okay. Yeah, so what does a bit look like?
0, 1, 0, like a 0,
Well,
1.
yeah. Forget about all the 0s, right? Just to
Yes.
make it clear,
0,
right?
yeah.
The easiest way to calculate a bit is one single character, right, on your computer. One single character. Like you can say this letter A, or this letter E, or this letter G. One single character,
Yes.
right, can be compared to a bit. So if I want to say how many bits is in this information here, I count 1, 2, 3, 4, 5, 6, 7, 8, approximately 8 bits. Okay? So I know it's in zeros and ones and all that stuff, but just a way for us to understand, right? You can compare a bit, 1 bit. So 1 bit, right, is the smallest unit of data. Now we have 8 bits is equal to
Byte.
1
Byte.
byte, right? So the smallest unit of data is a bit. Like I said, the smallest unit of data is a bit, and now 8 bits will be 1 byte, right? So 1 byte is equal to 8 bits. Now we have, so we take a byte and we say, okay, if you want to look at 1,000 bytes, then you get 1 MB. Sorry, not 1 MB, 1 KB, 1 kilobyte, right?
Yes.
So 1 bit is the smallest unit of data. 8 bits gives you 1 byte. 1,000 bytes gives you 1 kilobyte. Kilo is like 1,000, right? Kilometers, 1,000. All right, and then we keep going. 1,000 kilobytes is equal to what?
1 megabyte.
1 megabyte. Okay, 1 megabyte. So if I save this file is saved, right? If I save this file and I open up the file where it was saved, now let's see the size of this file. If I open up this, if I open this up properly, if I can find the size here, it should tell me the size of this file. Now look at this file is 3 kilobytes, right? Approximately 3 kilobytes. So if we are going to calculate 3 kilobytes, right? Like, okay, how many bits is 3 kilobytes? How many bits, right, is 3 kilobytes? Then we have to divide by 1,000 and divide by 8, right? So if I use my calculator here, say it again.
3,000.
3,000 what?
3,000 bytes, 3 kilobytes. It's equal to 3 kilobytes.
No, 3 kilobytes, right, is how many, if we want to convert it to bytes, then we divide it by, no, we multiply it by 1,000.
24,000.
So it's 24,000 what?
Bit.
Okay, bits, right? Okay, so, all right. So 1,000, okay, so we say 3 times 1,000, right? So that's 3,000 bytes. And then, and then do we multiply by 8 or divide by 8?
Yes.
Multiply by 8.
We divide by 8. No, we don't divide. We multiply by 8.
Yes.
Times 8.
8.
Yeah,
24.
times 8.
All right. So Anjuman is correct. So 24,000 bits.
Bit.
Okay. So that's how you do the calculation, right? Approximately 24,000 bits is what we have in here in this file. Okay. So if you see that question, you know, in an assignment says you have 3 kilobytes. Well, how many bits is that? Okay, so that's a good one there. Let me close this. So we keep going here. Now we have 1,000 megabytes is equal to 1 what?
Gigabyte.
1 gigabyte. Then we keep going. 1,000 gigabytes is equal to 1
Terabyte.
Do you guys know that?
Terabyte.
Terabyte. TB, terabyte. 1,000 terabytes is equal to 1 petabyte. 1,000 petabytes is equal to 1 what? you guys have given up.
1
Equal to a server.
What? You gave up? You given up?
Should be like
So
a
1
server.
petabyte. I think that's 1 ZB, zettabyte. 1,000 zettabyte No, I think it's ZETA, zettabyte, is equal to 1 YB, yottabyte, 1000 YOTABYTE is equal to 1 what? Okay, I'm going to stop there. But yeah, it's a lot. It's a lot, right?
Yes, a
actually,
lot.
I think it's exabyte. I think it's exabyte. 1000 exabytes is one. I think it's BB. I'll have to check that up. I think it's called a Bonderbyte or something like that. Something that sounds like that. But we're gonna see. We'll check it out. We'll kind of Google it and see what we find there, right? So I might be a little bit wrong in some of this, but that's how you calculate the speed of data. So basically, when you want to know the speed, for example, this file here, right? Open the file. Yes, save. Yeah. All right. So this file was 3 kilobytes, right? Now, when you see, just to be clear, when you see uppercase like KB, that is file size. But when you see KB, that is, let me say data file size. Here is data speed. Right, so uppercase letters is the size of your file. Lowercase letters is the speed of your data. So if I go back to my control panel, if you go back here, and you go to, let's see, if you go to network right here, network status and task right here, and then you click on Ethernet. So try to do that. Go back to your control panel, go to view network status and task, and then go to Ethernet right here. Now you're going to see right here that it tells me that my speed is 100, right? M uppercase with a small b, right there, right? It's a little bit small, right? Let me magnify it so you guys can see properly. All right, so you see that right there? 100 Mbps. Oops. Where's my magnifier? Let me get out of it. Yeah, it's just getting to, everything is too big. So when you see that size, right, like KB here, right, that is about the speed. So you can see right here, my speed is, right now my speed is 100 Mbps. What is Mbps? Megabits per second. Right? Megabits per second. Right? So when you see uppercase M, lowercase b, megabit, not megabyte, megabits per second. Because when megabits per second. Because when you're transferring data, right, you transfer data in bits per second, right? Bits per second. So right here, it can transfer on my computer 100 megabits per second. Yeah. Right? So, so for example, if I have a file, right? If I have a file that is, say, 1 gigabit, right? This is like some math now, right? So let's say we have a file that is 1 gigabit. Now it depends on the transfer rate, right? Let's say the transfer rate is, okay, like my computer here, right? Transfer rate is 100 megabits per second. So how long will it take to transfer the file? See, that's a lot of math. So first of all, you have to convert 1 gigabit, right? Sorry, 1 gigabyte. We have to convert 1 gigabyte to bits. So it's a little bit of math. After the class, I'll have you guys do that maybe for your assignment or something. So if the file is 1 gigabyte, you want to transfer file size, and then we'll say transfer rate. So the file is 1 gigabyte, transfer rate is 100 megabits per second. You have to transfer 1 gigabyte, right, to bits, and then you divide by 100 megabits per second. It will tell you how long it will take to transfer the file.
Now it is 24
make sense?
per second. 24,000.
So no, we don't have to do it right now. We'll do it later. You do it later, right? But
yes.
Just to give you the idea of how we calculate the transfer speed, you have to know the transfer rate first, right? Like if a car is driving, right? Back to this picture. Let's say right here. Oh, I need to get this thing out of the way. Okay. So let's say all right, so if you're driving this car, right, and you want to know, well, how long will it take for this car to get to where? To get to New York. Okay? Then you have to know how fast is the car going. If the car is going at 40 miles per hour, now we know that New York is about 3.5 or 4 hours, right? So if it takes you 4 hours to get to, New York is 4 hours. Now this car is going at 40 miles per hour. So you have to know how far is New York, how many miles is New York, right? New York is about 250 miles, something like that. So 250 miles, well, this car is going at 40 miles per hour. It will give you an idea of how long it will take to get there, right? So let's say New York is 250 miles, but the car is going at 40 miles per hour, right? So how long will it take for the car to get there? You just divide. 250 divided by 40. How many hours? What? Just do the math.
60.
New York is 250.
6.
How many hours? 6 hours?
6 hours and 27. Around 6 hours.
You can use your calculator. 250 miles divided by 40. It's about 6.25. It will get there in about 7 hours because the guy is going very slow. All right? So in a sense, that is how we calculate the speed of data. Okay? Now let's go back to what the book is talking about, the speed of your memory stick. Okay? Back to speed of your memory stick. So let's close this out here. Okay, so right here, it says that, where is it here? It says, okay, the data rate is 133 megabytes per second, right? So, of course, you can break this down to bits, but you see the B here is uppercase B, so this is transferred in megabytes. Okay, so 133 megabytes per second, right? Depending on, depending on your, it says if it's 33 megahertz or 66 megahertz, right? Over a 32-bit channel. So basically, the speed is about 133 megabytes per second, right? Now, the most common is 133 megabytes per second. So you can see that's the speed, right? So on the PCI slot, for data to move on your computer, right? When you're using your computer and everything's moving, the speed of your computer, basically, it's approximately 133 megabytes per second. You say that's the most common. All right? So hopefully, maybe that makes a little bit more sense to you guys on how data is, how we talk about the speed of data. Okay? All right, so let's get going here. So right here it says, Okay, so let's see. So 133 megabytes per second being the most common. PCI is a shared bus technology topology, which means that mixing 33 and 66 adapters in a 66 megahertz system will slow all adapters to 33. So I think just the important thing that for you to get a hold of is that 133. So you can imagine how much data, right, is being moved around using 133 megabytes per second. Okay. Okay, so something else here. The quick way to figure out how fast it is multiply it by the channel width. So it says the channel width right here. To get it, that's if you want to get the data rate, right? To get data rates, multiply by the channel width. So 33 megahertz will be 33 times 4. See, 33 times 4 gives you about 132. But then they just kind of, what it says is they round it up. 133 megabytes per second. 266 megabytes per second. All right. So just to give you an idea of how that works. Okay, so that's PCI, the PCI slots, the AGP slots here. That's accelerated graphics ports. They're known for video cards, right? So if you have a video card, you want to install a video card for graphics and games and things like that. So the AGP slots are for video cards. But it says that they're kind of old, so we have newer PCI Express slots right now. So the AGPs are a little bit slow, or rather they're kind of old. But this is kind of like what it looks like here, an AGP slot compared to a PC. So this is the AGP slot, this is the PCI slot. Okay. Now the data rate here is 266 megabytes per second. So the PCI, remember the PCI was what? 130, what's that? 133 megabytes per second. That's for your PCI. For the AGP, it is, what is it again? It's 266 megabytes per second.
It's double.
Say it again.
It's double than
PCI. Yeah, exactly. Yeah, it's kind of like double, exactly. So that will make it that particular device or that particular specification will be faster, right? Okay. Now let's see the PCIe. So PCIe is PCI Express. So the most common today, right? The most common you're going to find today is the PCI Express. So it was designed to replace. So it's going to replace those two, right? So on your on any current motherboard, you're going to find mostly the PCIe. It says right here it was designed to replace the AGP and PCI. So let's see what is the speed of that one there. What does it say about the speed of it? Let's keep going here. All right, look at that here. So it says, compared to its predecessors, PCIe is fast, right? It will run at 500. So it's like more than twice. 500 megabits per second. Okay, which is comparable to the best PCI can offer, 533. So 500 megabits per second. Actually, wait a minute. The current PCIe standard is PCIe 4.0, and it can operate at 31.5 gigabits per second. So look at that.
Yeah, it's very fast.
It's the very fastest.
It is more than fast. Right, 31.5. Anjuman, you guys, I'm getting a lot of feedback. Can you mute yourself for a second?
Yes.
Yeah, just mute it if you're not talking right now, because we're getting a lot of feedback there. Okay? Okay. So you guys see that PCIe 4. What's it right here? So PCIe 4.0, and with it a 16 card can operate at 31.5 gigabits per second. So that's a lot. Is somebody asking a question?
PCIe
Is someone asking a question?
No, that sounds from Anjuma.
Okay, Anjuma, we're getting a lot of feedback from you, so maybe you got to mute yourself. Actually, I'm going to mute you myself. Okay. All right. So give us an idea of the different speeds here, right?
No.
All right. So give us an idea of different speeds that we see on the different systems here, right? So let's see something else here. Actually, we missed something here, I think. All right, so it says right here, see, there are 7 different speeds supported by PCIe. And it has the ×1, which is, you say, by 1. So you have by 1, by 2, by 4, by 8, by 12, by 16, and by 32. So the most common are by 1, by 4, by 16. They're the most common, right? So how do we know, what is by 1 or by 2 or by 3, right? So it says that a slot that supports a particular speed will be of a specific physical size, right? So, depends on what the size is. So a by 8 slot is longer than a by 1 slot. So the longer the slot, right? The longer the slot, then the better the performance, right? So as a result, a by 8 slot is longer than a by 1 slot, but shorter than a by 16 slot. So every PCI slot has a 22-pin portion. So that's the figure 8 there, right here. I think it's referring to this here. Okay. The pins are where you stick where you put the put the card in. Okay. All right, so right here, it says right here from top to bottom, this is a 16 slot right here. This is a 1 slot by 1 by 1, and this is an old PCI slot, right? So just, to look at the picture again. Right here, this is a by 16. These two are by 1 by 1, and this is a PCI slot. So those are expansion slots that you can use for a lot of different items. Okay. All right. Let's go to, let me open this up 1 second here. Now remember when we looked at the questions, right? Let's see if we can answer any of these questions so far. So right here, number 3. Which type of expansion slot provides the fastest data transfer speed? So what's the correct answer now?
Can I say?
Yeah.
Yeah. So now it is PCIe X16.
Yeah. Okay. Remember you said 64, right? The other time?
Yes. That same question I answered that before.
Exactly.
Yeah.
So 16, there's no 64. We know that, we have by 16. And that's the picture that we just saw up there. Okay. All right, let's keep going back to the summary. So that's something about the RAM, right? The motherboard, the CPU, and the RAM. It's used as temporary storage for data, and the processor and applications need. So basically, the more RAM you have on your computer, the faster it's going to be, right? The more it can process, the more it can process, the more it can perform. And also, when you see the pictures, right? If you see the pictures, like back up here, let me just go there. Yep. All right. So if you see a picture like this, and it says, what kind of PCI slots are this? This is your PCI. This is by 1. PCIe by 1 by 1. This is by 16, right? So, different sizes of those expansion slots. Okay. Let's go on here to some other information. So we looked at the PCI slots. Let's see. Let me just scroll down here. Okay, so let's go down here to see. Actually, wait a minute. Let's kind of touch a few things here that we kind of jumped over. So disk controllers, right here, basically says hard drive connectors. So I guess it's talking about here a hard drive, right? A hard drive is where your data is stored. So that's what it's referring to there. So there are a few different hard drive standard connectors. Connectors are how you connect the hard drive, right? Connect the hard drive to the computer. So let's go here and say hard drive. So let's see hard drive connector on your computer. All right, so right here, if I use this picture, all right, so you can see that cable, right? This cable right here, right? So this is your hard drive on your computer, and this is the cable that connects your hard drive to the motherboard. If we go back to that YouTube picture, so let's see YouTube video. So let's see another search here. So let's see the hard drive connectors. All right, so let's see this guy here. All right, so that's a hard drive that's inside your computer. This guy's on a 640 gigabytes hard drive. Let's see if we can just move this forward a little bit here. All right, so those are the slots right there. You see those slots there on the hard drive? And so you have some connectors or wires, right? Some wires or connectors that connect the hard drive. All right, so those are the connectors. So you see that as an example of one of the connectors that connects the hard drive to the motherboard. All right, so basically he's going to connect that hard drive to, so you can see the mounts there, right? They look alike, so it's just going to go in there. All right, and it goes into that section right there. You see that? So that's the connector. That's what we're talking about now, right? The connector, the connector for the hard drive, and then this cable goes connected to the motherboard. All right, so let's go back here and see this information. All right, so right here it says that the older, so there are a few different hard drive connectors right here, a few different hard drive connectors. The older one you will run into is called IDE, that is Integrated Drive Electronics, or PATA, Parallel ATA, PATA, right? Parallel ATA. So it's IDE, Integrated Drive Electronics, or. Now, the newer one, like I think the one that guy showed us in the YouTube, this video here, this YouTube here, this one he's looking at, the newer and much faster one is called Serial ATA, SATA. So, it gets connected here. So let's see here. So, IDE hard drive connectors, they connect here. SATA hard drive connectors. Let's see. All right, so one end goes to the hard drive, and then the other end gets connected in one of the slots here. So right here it says the newer and much faster one is called Serial ATA, SATA, and figure 1.9. This figure here, this picture shows the two IDE connectors. The black and the white ones are the same. These two are the same. And the other one shows 4 connectors. So this is 2, and this is 4 different. So it says right here, you see that SATA. So they're all very well labeled. SATA 2, SATA 4, and right here. So you connect one from the end. So this one here this is like an external. So he has a USB. So he's using an external hard drive. But the internal hard drive, let's see, let's get an internal one. Okay, right here. This is a good one. All right, this is much better. Let's go here. All right, so down here is where he's connecting it to. Down here is what we're trying to look at, down here. All the connections down here. All right, so you see those slots that he's pointing you to right there. All right, so you see, so that's the connector from the hard drive. It's going to connect it to, okay, that's it right there. Okay. All right, so he's connecting that SATA, so that SATA cable, right? That SATA cable is connected to the motherboard, and then the other end is connected to the hard drive, just like that. Okay? So if that makes some sense to you guys, that's what we're trying to look at here, is the different connecting points. So this one here, up here, it shows the, what's it say here? SATA. So this here is the IDE, right? This is the IDE. So this is like the older one, and it says that the newer one is, it looks like this. This is the newer connection, all right? This is the newer one. So let's see if we can find it here in this. So hard drive connect to SATA. All right, let's see if we find one like that. Okay, I think this one is a good one here. Well, this is that's a hard drive or a laptop actually. All right, so he's going to connect this one to a laptop. So that's what the cable looks like right there. Right, so he's just talking about connections, right? Let's not spend too much time there. Your different connections and connectors, okay? All right, so that's what that is. If you opened up that computer, you will see the different types there. But so we have, so the names are important to know, right? So the older ones, the older versions are your IDE, Integrated Electronics IDE, or Parallel PATA, and the more current ones are Serial ATA SATA. So this is the older one, and this is what the newer one looks like. Okay, and then it talks about power connectors, which is how you get the power into the computer. All right. All right, let's move on to something else here. Let's look at the battery, CMOS and the CMOS battery. So your PC has to keep certain things turned on or off, right? So let's see how your computer is able to manage using manage the power with the power features, right? Your PC has to keep certain settings when it's turned off, and its power cord is unplugged, right? Such as the date and the time. So even if you unplug the power from your computer, it's still going to keep the time. Okay, so let's look at how that works here. So it says right here, these settings are kept in a special memory chip called the complementary metal oxide semiconductor, CMOS, pronounced CMOS, right? CMOS. The CMOS chip must have power constantly or it will lose its information. All right, so to prevent CMOS from losing its information, the motherboard includes a small battery called the CMOS battery. So what's the CMOS battery look like? Let's see. The CMOS, CMOS battery.
It's like a button.
Yeah, it's like a very tiny, exactly like that. Something like very tiny right there. So that's what it looks like, right? Right there in your computer. Very small, looks like a battery that you can use for, like a watch or something. Some of those batteries there. That's it right there. So that's the CMOS, CMOS battery. Okay, so it says, so you install the CMOS battery to power the CMOS memory, right? The CMOS is how your computer remembers everything you did on your computer. If there's no CMOS battery, nothing is going to ever be saved on your computer, right? So it's saying right here, to prevent the CMOS from losing its information, right? So the CMOS is how the information on your computer is stored, right? So very important, the CMOS and the CMOS battery. So like the settings, right? The settings on your computer. So if I, for example, if I set my desktop this way and I shut down my computer, well, the CMOS battery helps to remember what I did on my computer, right? Like my settings, like my date and time and things like that, right? So it works constantly. But this battery is what gives it power. So this battery must not die. If it dies, you got to change it. See right here, it says, if your system does not retain its configuration, it's possible that the CMOS battery has failed. So every time you save something on your computer or you change a setting, if it doesn't get saved, maybe your battery needs to be replaced. So right here it says replacing it is similar to a watch battery. Just go and buy a new one, and replace it. Right? So all these different components are vital to helping a computer stay work. All these different things we've seen here. Yeah, go ahead.
I have a question. When should we know that is the right time to replace the CMOS battery?
Right here it says, if your system does not retain its configuration information, so let's say let's say you set the clock or you set your desktop or something and you shut it down and you put it back on and nothing, everything is just changing all the time. Then it says right here, it's possible that the CMOS battery has failed. Right? So, I mean, actually, I hear that it takes a long time for it to fail, like maybe 10 years, like a very long time. Now, most computers don't last up to 10 years. Maybe after 4 or 5 years, you have to replace your computer, your desk, or your laptop or something, right? So it's possible that your CMOS battery will last longer than your actual computer. So you probably don't have to worry about it, But if you notice that your settings are always changing and nothing stays the same, then maybe your CMOS battery has failed. And if we look here, let's say how long does a CMOS battery last? What does it say? Look at that, 2 to 10 years, right? So a CMOS battery gets about once it's been charged, it lasts about 2 to 10 years from when it's manufactured. So it says the more you leave your laptop plugged in, the longer your battery will last. But some people think you have to unplug your computer for it to last. Well, it looks like you need to keep it plugged in for it to last. So interesting, right? Okay, that's your question, Alex.
All right, thank you.
So so that's your question there. How do I know if I need to change it? All of the settings like drive and all those things will be changed. So all your settings will just change. And then you see all these funny messages there. And the computer may be shutting down every once in a while. It will just shut down, right? Just shut down. You start it again, it shuts down. Basically, when your life starts getting, when you start becoming miserable with your computer, maybe that's the thing that's causing it, right? Your CMOS. All right, so let's see a few more things here. The back panel connectors. So now behind your computer, your laptop or your desktop, you're going to see a whole lot of this different connecting points here, right? Let's take a look at it. They're called peripherals and connectors. Your audio will go here. Your USBs will go here. Your monitor will go in here. You have 2 different types of monitors that can go in here. This is a VGA port. So let's see. So all these connectors are connected to, it says right here, generally speaking, all of these connectors are connected to one of 2 things, the motherboard or an expansion card. So if you have, USB drives, you have video, right, is connected to one of your expansion slots, right, those PCIe slots. So we're going to look at all these details like in the next chapter, right? Then let's see. So on the front of your computer, the front of your computer, front panel, the power. I mean, you guys should, see all that information. All right, so the front panel of your desktop, let's see a picture here. Where is it? All right, so this is a good one here. All right, so the front of your computer, you're gonna see a power button, right? That's how you start, and I don't see it here. Maybe it's, I don't know, maybe this one here, something. Let me get a better one. Is that a computer? That doesn't look like a computer to me. Let me see. Okay, let's see the front of a just give me 1 sec. Okay, right here. Well, this is an older computer, much older, really much older. Anyway, I think it does the job we're trying to do. Much older. All right, so basically, most computers, right, like it says here, will have a power button here. You turn it on and off right here. You have a reset button. You have all these different lights. You know, your computer is working. It's going on, you know, it's like blinking lights to tell you that the computer is working. You have audio ports where you can plug your headphones or your speakers at the back of the computer. And you have other connectors there. Actually, let me get a more, let's see if we can find something more current a little bit here. That is probably more current. Yeah, so front or even at the back. All right, so right there you're going to see, you know, different connectors on your computer for, you know, different things you want to do there. All right. Okay. Okay, so back to this description we saw earlier, right? This description, if you guys remember. So we looked at the manufacturer type, the USBs, the USB points there, the chipset. We looked at the motherboard, the PCIe by 16. So maybe that makes some more sense to you guys now. Right here, it has the SATA connectors. So you're going to find, you know, Wi-Fi, Bluetooth, USB cables, right? USB, should I say, ports on your computer also. So those different connecting points, you're going to find them on your computer. So let's see something here. All right, so that's a good example there of, you know, the different, okay, let's actually look at this one here. All right, so that's your USB. So you have actually two different types of USBs. You have the regular USB, which I think is 2.0, and you have the 3.0 USB, which is kind of faster, right? We'll see in chapter 2, but this is your USB. Right here, you have your audio ports. And they all have little pictures, right? They all have little pictures to tell you, let's see what is going on there. The different pictures. Let me see that one there. Okay, if we zoom in on this one, yeah, you might see little different pictures to describe, you know, somewhere around it. This is USB, different connectors, connecting points there, right? Actually, I think the other one was a better picture than this one. Yeah. So you can see USB 3.0. You can see your Ethernet, right, to connect your modem or your router to these different ports here. All right. So those are the different components you're going to find on your computer. processors. The processor is the most important component on the motherboard, the role of the central processing unit. So this is the CPU now, right? So this is the CPU, this little device here. It says the role of the CPU is to control and direct all the activities on the computer, right? The role of the CPU is to control and direct all activities on the computer. So the CPU is often called the brain of the computer. Okay? Now, it doesn't think by itself. Basically, it has to be programmed, but when you say the brain, it means that it does a lot of work to make that computer work. All right, so your CPU or your processor, it says they're small chips, and they have millions of transistors or things that send back and forth information. So Intel and Intel and AMD. Intel and AMD are the two largest CPU manufacturers. And this is what it looks like. This is an AMD processor. And let's see an Intel processor down here. Can we see an Intel processor here? Where is it? It's not showing us an Intel here. Anyway, let's go back up. I don't know why it didn't show us Intel. Anyway, no problem. So let's see a CPU here. All right, so your desktop CPU, well, now some people, a lot of people call your computer, right, the box, they call it the CPU, right, the box, but the actual chip is what we refer to as CPU. So this is the chip inside, right? This chip is installed in your computer. That is actually what the CPU is. But people refer to the box also of your computer as the CPU. That's the unit. That's the case. Inside that box is where you find the CPU chip. And this chip might be from Intel, right? Might be Intel or AMD. That's what it says here, right? AMD and they're usually square. The shape is square. All right. So the characteristics of your CPU, it says the most important characteristic your CPU, your processor can have is its compatibility. If it fits into the motherboard, right? If it fits. And then right here we have some, it says terms, 32-bit, 64-bit. Like if I go back to my settings, right here it says that my computer is a 64-bit operating system by 64-base processor, right? So what is 64-bit or by 64? So right here, it says processors that you find today will be labeled as 32-bit or 64-bit. What this refers to is the set of data lines between the CPU and the primary memory of the system. So 32 or 64 bits wide. Okay. So computers usually have two types of processors. So you can say your computer is 32-bit or 64-bit, right? It's the processing power, how fast it processes things. So you will find a 32-bit and 64-bit processor designed for all types of computers, such as laptops, desktops, workstations, and servers. Actually, I missed something here. So right here it says the wider the bus, right? The bus is like, you know, the data lines, like it says, right? The data lines, how much data can be processed. So the more data can be processed per unit of time, every second, the more work can be performed. So are you guys here? Are you guys asleep? You guys are here,
Yes,
right?
yes.
Yes.
Are you guys getting this, or am I totally confusing you guys? Are you guys getting it, or are you confused? Is it making sense?
Yeah, it makes sense. It's all fine.
Okay. All right. So if your computer is a 64-bit CPU or the chip, then it says it can run this by 64 versions of Microsoft operating system. The external system data will always be 64 bits wide.
I
So
didn't
say basically.
understand. I have a question. Can I have a question?
Sure.
I didn't understood why this wide over here, 32 or 64 bits wide.
Okay. Let me use maybe a good example here. So let's say all right. So I'm gonna look at this here. Okay. So let's say you have. Okay. Let's look at this highway here, right? Let's look at this highway, right?
Oh.
Now compare that highway to. Okay, look at this highway first. Look at this highway here. You see all the traffic?
Yes.
So what it's saying is 32-bit and 64-bit is like having the lanes on the road. If you have 32, well, it's not going to go so fast. I mean, look at all this traffic. Look at this traffic here. There's only one lane because there's some construction going on. But if you have many lanes, look at that. A lot of traffic can flow faster. So that's the comparison there. That when we talk about 32 and 64, it's like you have more lanes of data to flow.
Okay.
Right? So it's like on your computer, you have what you call buses. So, sorry, on your motherboard, that's what actually, let me go back there. Where is it? That's what it says here. 1 second. Let me open that up. Okay. So right here it says, look at that. What this refers to is the set of data lines between the CPU and the primary memory. It's like lines. So let's see, motherboard bus lines. So let me show you what it looks like in the motherboard, right? In the motherboard, those lines look something like this. Yeah. Where is it? So, something like this, right? So these are actual lines that go on your motherboard, right? So they look like lanes of a highway.
Okay.
Right? So if you have 64, you can have more data flowing back and forth. Like a lot more instructions can go back and forth.
Okay, understood.
So that's the whole idea, right? 32-bit and 64-bit, you have a lot more lines that can go between your CPU, between the chip, right, and all the memory of the system. A lot of instructions are going back and forth, back and forth, back and forth. It's like, imagine yourself right now we all have one brain in our head, right? Imagine if you have 10 brains. Like you can do so many things at the same time. You can talk, you can stand up, you can eat, you can sleep, all at the same time. You can teach this class, you can go to work, you can talk to your children, be on the phone, text, type. but you only have one brain, so you can only do so much. So that's the idea there, right? That they're like lines on a computer that help the processing of information. And it says right here, ARM refers to a type of processor that uses an architecture known as Reduced Instruction Set Computing, RISC. So it says the differences between RISC and CISC is how the processors do the math and the instructions that the software needs to give them to do the math. So basically, some of these guys can, work faster than the others, depending on if you use the RISC or, CISC. So if you read this part here, what does it say here? It says the differences between RISC and CISC are way beyond the scope of the exam. So ARM processors are made in both 32 and 64-bit versions, so you find them in workstations and servers. Because they can be made smaller and produce less heat, ARM processors are generally used in devices that are tablet size. So mobile phones and stuff like that use ARMs. Something else here says another term, we're going to round this up now, you will hear in terms of architecture is the number of cores. So right here you might see Intel Core. So your computer on your laptop, you might see it saying something about cores. You might see this information on your computer. It says iCore or something on the laptop. I mean, we all see that sometimes when you buy a computer. Yeah, so that sticker might be on your computer and says, Intel Core. So it's saying right here that what is that core, right? What does it mean? It says you might see something labeled dual core, quad core, or even 16 core. This is a Core i7. So it says what it does is to keep making better and faster processors every year, manufacturers constantly have to find ways to increase the number of instructions a processor can handle per second, right? So it's like if you want to have more lanes on the highway, right? You want the cars to go faster. What do? We might add more lanes, right? If you're in a place where there's a lot of congestion,
update.
If there's a lot of
day by day update means update.
Say that again. I didn't get that. Say that again, please.
Yes, Anjuman, I said that
your audio is not very good at all. Your audio is not very good.
Day by day.
Your audio is not good at all, Anjuman. Your audio is not good at all. You know what you can do with your audio, right? What you can do with your audio is your audio is not good at all. What you can do with your audio, listen 1 second. Listen 1 second. Listen 1 second. No, listen 1 second. Your audio is not good at all. What you can do, right, is to use your phone. Can you listen at 1 second? What you can do is use your phone, right? So call into the Zoom number.
Yes,
I'm not hearing what you're saying. Can you guys hear what Anjuman is saying?
Not clear.
Not clear.
Not clear at all. No.
Yeah.
Anyway, we've come to the end of it today, so we're going to wrap this up. we'll finish this up on well, we'll just continue on Wednesday.
Yes.
Let me just see what else we have in chapter 1.
Yes. No. No. Now I hear me.
Anyway, no, your audio is not very good at all. So we're going to continue on Wednesday and try to finish up some of these other things here. Okay, we did this today. Actually, we looked at the common units of data, so we don't
Yes,
have to.
I'm
We
trying
we can skip that part. And then we look at some of the other things there, the cooling. Okay, we already looked at what the expansion services do, right? Like the video cards and network cards, the audio cards, all the expansions you can do on your computer. So we're going to look at that, and then we can wrap up chapter 1. Okay, well, that's all I got.
Good.
Any questions?
No, we are good.
Very good. I do same.
Okay, let's do the attendance, and we can wrap this up. But when we're done with chapter 1, I think we'll have a good idea of what some of these things here is talking about. Okay. All right. I'm gonna stop the sharing now. Let's go to Canvas and let's do the attendance.